Dear student, today, okay, let we discuss about the important chemical reaction of phenol. Okay, so we learned in the previous class, the preparation of the phenol. I think you understand, right? Okay, remember it. Now here let us discuss about the chemical, okay, important chemical reactions of the phenol here. Okay, let us start the important name reaction of the phenol. See in your organic chemistry, right? So name reactions are very important. Okay, what are the name reactions? Okay, related to the particular compounds. Okay, in the phenols. Okay, what are the important name reactions are there, right? So I give you here number one. Reimer Tiemann reaction. Okay, number two. Kolbe reaction. Number three. Coupling reaction. Number four. Scotten Baumann reaction. Okay, these four are very common and very important. Okay, chemical reaction, name reaction of the phenols. Okay, so please don't forget, right? So let me explain one by one. Okay, so how is the Reimer Tiemann reaction? The Reimer Tiemann reaction. Okay, here. So here is the conversion. So you please remember the number one. Conversion of phenol into, okay, in what a compound is converted, that is the 2 hydroxy benzaldehyde. So the name of this 2 hydroxy benzaldehyde commercially what we call salicylaldehyde, right? This is the major product. Now here, so the importance of the Reimer Tiemann reaction is number one is the conversion of phenol into the 2 hydroxy benzaldehyde, that is the salicylaldehyde. That means this is the formation of the salicylaldehyde from the phenol. Now here, what is the important reagent we use here? Important reagent, that is the chloroform. Then in presence of the chloroform, what is this formula? This is the chloroform, right? Okay, in presence of the sodium hydroxide. Sodium hydroxide, I write here. Sodium hydroxide. Okay, don't forget number one in the Reimer Tiemann reaction. What is the Reimer Tiemann reaction? Is the conversion of the phenol into the 2 hydroxy benzaldehyde, that means salicylaldehyde. So what is the our important reagent used here? So this phenol is treated with a chloroform and in presence of sodium hydroxide here. Then now, so here is the reactions mechanisms followed. Okay, what is the type of the mechanism followed? That is the electrophilic substitution reactions. Okay, the main mechanism of the Reimer Tiemann reaction follow, that is the electrophilic substitution reaction. Here electrophilic substitution reaction normally, understand, our aromatic ring, so in the phenol, okay, so this is the aromatic ring. Okay, normally our aromatic ring, that means benzene rings, what is the characteristic reactions follow, that is the electrophilic substitution reaction. Here in our aromatic ring, only the thing is that what do we here, one of the hydrogen from the aromatic carbon, one of the hydrogen, it may be from here, it may be from here, it may be from here, right? One of the hydrogen is replaced by the electrophile. So Electrophile is the attacking reagent. Okay, electrophile is the attacking reagent which always attack to the carbon, okay, where the electron density is very high, right? So here, so electrophile is normally carry the positive charge or electron deficient species here. So in the Reimer-Tiemann reaction, okay, what is the electrophile using here? So in our Reimer-Tiemann reaction, the electrophile is, so we write it, this is the electron pair, carbon, and this is the 2 chlorine. So this is the electrophile. What is the name of this electrophile? That is the dichlorocarbon. This is the electrophile, okay, which is generated from the our reagent chloroform and the sodium hydroxide. Now how this electrophile is generated? I just write here. This is the OH minus from the sodium hydroxide. This is from sodium hydroxide plus chloroform. Now it's formed the compound here, that is okay Cl3 minus, then plus water form. This is the reversible reaction. Now from this CCl3, now here CCl3, this is the negative charge, and it's given here the Cl minus and plus, that is the 1 CCl2, then 2 electron pairs remain. So this is the electrophile which is generated from these reactions, right? So don't forget what are the importance, okay, idea required to understand in our Reimer-Tiemann reaction. Here number 1, I just tell you what are the key importance of the Reimer-Tiemann reaction. I already mentioned here. This is the conversion from the phenol into the salicylaldehyde, and what is the reagents used, sodium hydroxide and chloroform, and what is the reaction follow, what is the reaction mechanism follow, electrophilic substitution reaction. And now in this Reimer-Tiemann reaction, what is the electrophile? That is the dichlorocarbon, right? So now how is the reactions written here? The reaction, so you can see in your book also. Now here, the reaction page. See, this is the phenol. Now, so in this reaction, okay, the first reagent we use here, chloroform, and the second reagent what we use, that is the sodium hydroxide. Now, in this reagent, okay, using the reagents, the phenol, it formed our compound like this. So this is the intermediate, what we compounds from, this is the intermediate. Then after the intermediate, so what's the reactions found here? Again sodium hydroxide. Now it's formed here, this sodium, right? What is the compound formed here? This is the sodium phenoxide. Here we write here this one, and followed by the acidification. This is the acidification. What is the compound formed here? I just remove these things. Now what is the compound here? This is the, this sodium is removed by the hydrogen. Now it's formed like this. So this is the compound. Now here the main parent name is the benzaldehyde. So here in the benzaldehyde, 2 position OH group. So that is the compound here, 2-hydroxy. This is the benzaldehyde. So commercially, what is the name of this compound is salicylaldehyde, right? So we have another isomer of this 2-hydroxybenzaldehyde is compound is formed, that is the in the 4th position. In the 4th position. Now I write this one is the benzaldehyde. So let me start counting 1, 2, 3, 4. This is the para position. This is the auto position. So we can say this is the auto or para. Okay, this is the auto position. Now when we write it here, so this OH group I write here. So starting from this 1, 2, 3, 4. This is the 4th position. What is the? This is the 4 hydroxy benzaldehyde. So this is the para position, that is the para isomer. Then this is the O2 isomer. So the O2 isomer of the our hydroxybenzaldehyde, that is what we call salicylaldehyde. So this is the major product. This is the major product. This is the minor product. So we don't consider the minor product. We only consider the major product. So when you write the Reimer-Tiemann reaction, you just write this reaction steps. Okay. Now here in the reaction steps, what we should remember that. So what is the intermediate form in between this reaction? So that is what we just can write this one, right? And here the just I remind you again. Reimer-Tiemann reaction is the conversion from the phenol to salicylaldehyde. What is the reagent? Chloroform and sodium hydroxide. So one more reagent is here, that is the acid. We can use the dilute hydrochloric acid. We can just write another reagent also. But in this reaction, okay, what is the mechanism followed? That is the electrophilic substitution reaction. Understand? Then now, okay, what is the electrophile? Because this is the electrophilic substitution reaction. So what is the electrophiles we using here? That is the dichlorocarbon. Just I write here dichlorocarbon is the electrophile. Understand? So this is the importance of the our Reimer-Tiemann reaction. Okay, don't forget. Okay. Now next today. The next, what is the name reaction? That is the Kolbe reaction. Kolbe reaction, that is the Kolbe reaction. Kolbe reaction, okay? So, let me write here the importance of the Kolbe reaction. Here is the first, number one, and number two. So, Kolbe reaction is the conversion of phenol into, okay, here the difference is salicylic acid. So what is the chemical name of this salicylic acid? That we write here 2 hydroxy benzoic acid. Okay, that is what we call salicylic acid. Now here this phenol converted into the salicylic acid, so that reaction is our Kolbe reaction. Here also, okay, what is the reagents using? What's the reagents used here? So the most important reagent is carbon dioxide and another is sodium hydroxide. Okay. Now using the carbon dioxide and sodium hydroxide, this phenol converted into the salicylic acid. And here also, what is the types of the reaction mechanism follow? This also electrophilic substitution reaction. Electrophilic substitution reaction. Okay. If this Kolbe reaction followed electrophilic substitution, what is our main electrophile? So here is the electrophile. What is electrophile? Carbon dioxide is an electrophile we using here. Don't forget. Okay. Then now in this reaction, okay. So what is our product form? 2-hydroxybenzoic acid. That means phenol converted into the salicylic acid. In case the presence of the carbon dioxide and sodium hydroxide, what is the name of the reaction? That is the Kolbe reaction. Okay. So how the reactions written here? That is the reaction we write here. This is the phenol. Now, firstly we react with the sodium hydroxide. Then this sodium hydroxide we just react with the phenol. It's from the sodium phenoxide. Okay. Then sodium phenoxide when it reacts with the carbon dioxide. So here the temperature mentioned. Okay, temperature is given here. So how much temperature is given here? Temperature here to 400. So 400 Kelvin. Then atmospheric pressure. Pressure is how much? Okay, the atmospheric pressure here the 4 to 7 atmospheric pressure. Under this pressure and the temperature, okay, the carbon dioxide reacts with the sodium phenoxide. So the compound formed here like this. Right, like this, right? Okay, that means in the second position of this, right, of this compound. So what is the name of this compound is sodium benzoate. So at the sodium benzoate 2 hydroxy sodium benzoate is formed. So this is the intermediate compound what it formed. Now this key compound is followed by the hydrolysis, that is the acid hydrolysis. We can write a dilute HCl. Then now what is the product formed here? This is the our 2 hydroxy benzoic acid. This is the 2 hydroxy benzoic acid. So commercially, what is the name of this compound? That is the salicylic acid. What we write it here, salicylic acid. So when you write the Kolbe reaction, so you just write this reaction steps. Okay. So here, what's the important here? So number one, it's the conversion from the phenol into the salicylic acid. Now what is the reaction steps? Just we have to follow it. And what are the reagent? Carbon dioxide and sodium hydroxide are the main reagent. And what temperature should be maintained? 400 Kelvin. And the atmospheric pressure is the 4 to 7 atmospheric pressure. We have to maintain the pressure. Now here, what is the type of the mechanism followed? That is electrophilic substitution reaction. And what is the electrophile we using here? Carbon dioxide. So now here, so the products formed here, we have a 2K isomer. One is a 2 hydroxy benzoic acid, another is the 4K hydroxy benzoic acid. We have a 2 isomer, but this 2 hydroxy benzoic acid is the major product we consider. Our 4, the second isomer, that is the minor isomer, we don't consider here. So this is the importance of our Kolbe reaction here. So this salicylic acid we can prepare from the phenols, but in 2 different types of the reaction here. Okay, now I just write here. So number one, I write here. This is the phenol, right? Okay. Now here I write 2 different types of the reaction. Now here, when we take the phenol in presence of the amine reaction with the carbon dioxide, and I write a number 1 carbon dioxide, number 2 is the sodium hydroxide. We took it here. This reagent, when we took it at what temperature? 400 Kelvin, and the pressure is 4 to 7 atmospheric pressure. Under this condition, this phenol is converted into the salicylic acid. That is I write here. This is the salicylic acid. So what is the name of this reaction? That I just remember it. That is the Kolbe reaction. Okay. So salicylic acid we can prepare from the phenols. Okay, when the phenol is treated with the carbon dioxide in presence of sodium hydroxide at this temperature and at its atmospheric pressure. So salicylic acid is formed. Now another method is here, right? So in our reaction phenols, when we react with the chloroform, in presence of the sodium hydroxide followed by the acidification, right here. So what was the products found here? You remember that is the aldehyde, not an acidic group. Here is aldehyde. Understand? So what was the name of the reaction? That is the what is the reaction? That is the Reimer Tiemann reaction. This is the difference between the Reimer Tiemann reaction. Now in the Reimer Tiemann reaction, phenols we use here, the reagent is the chloroform in presence of sodium hydroxide, and the compound is the salicylic. Salicylic, right? So that is the reaction. Name is Reimer Tiemann reaction. Here the name is Kolbe reaction. Here, but in the place of instead of chloroform, if we replace by the carbon tetrachloride in the same reagent we use it, but only the difference is instead of chloroform, if we take carbon tetrachloride, right? So the products found here, that's not a salicylic, that will be the salicylic acid, right? Don't forget. Okay, so but here the name is not a Reimer-Tiemann reaction. Okay, the name of the reaction when the chloroform we use it, that is the Reimer-Tiemann reaction. But only the thing is that chloroform replaced by the carbon tetrachloride, the product is not salicylic. What is the product will form? That is the salicylic acid. Okay. Now we have two different reagents we using here. Okay. The one reagent is the carbon tetrachloride in presence of sodium hydroxide. Another is the carbon dioxide in presence of sodium hydroxide. So we have the same product it found here, right? Don't forget. Then here, this salicylic acid, right? This salicylic acid is the one of the most important starting material. Salicylic acid. Alright. So salicylic acid is the one of the most important starting material for the preparation of the very important, okay, our medicine or drugs, right? What is the name of the drug? That is the aspirin. Okay, so I write aspirin. Okay, chemical name. What is the chemical name of the aspirin, right? So what is the chemical name? 2-acetoxy, right? That is the benzoic. Okay. 2-acetoxy. Okay. That means, okay, benzoic acid, right? 2-acetoxy benzoic acid. That is what we call aspirin. What is the structure of the aspirin? We write it here. So this is the structure of the aspirin, right? Okay. So now here, this aspirin, we know as a drug or medicine. Okay. So this aspirin is one of the most useful medicine or a drug for the kid. So what is the properties of the aspirin? One is the analgesic, that means pain reliever. Pain reliever. Another is the antipyretic. That means so that means that's only for the medicine what we use the so in our fever we use, that means reduce our body the fevers, right? That is the antipyretics. Another is the analgesic. So aspirin is the one of the important drugs which can be used in the analgesic as well as antipyretic, right? So this aspirin can be prepared from the salicylic acid. How is the reaction? So the type of the reaction, that is the acetylation of the salicylic acid. Acetylation of salicylic acid. So what it produces, that aspirin. You please remember that it's aspirin. So how is the reaction? That is salicylic acid. We just draw here salicylic acid. Then acetylation. How the acetylation products form? Now here, this is the salicylic acid. Now, so here for the acetylation we use the two reagents. One is this, I write here, or it can be write like this. It can be used another compound, that is this one. So if we write this one, what is the name of this compound? I just write here. So this compound, this is the compounds I write here. Now here, this part, this is what we call acetyl group. This is the acetyl group. This acetyl group is replaced this hydrogen, right? Similarly, this is the acetyl group. This is the acetyl group. This is the acetyl group. this acetyl group is replaced this hydrogen, right? It forms a compound like this. So here carbon double bond oxygen and it's formed like this, and nothing changed this, okay, carboxylic acid group. So this compound, what we call 2-acetoxy benzoic acid. What is the name of the our compound commercially? That is the aspirin. Okay, so this is the most important reaction. Okay, how the aspirin can be prepared, can be formed from the our salicylic acid, right? So what is the type of the reaction? That is the acetylation of the salicylic acid from the our aspirin. Okay, so don't forget. Okay, so that means salicylic acid is the one of the most important, okay, our starting material, so to form the our aspirin. Okay, don't forget. Number 3, that is the Schotten-Bowman reaction. Okay, so Schotten-Bowman reaction, that's the similar to our previous acetylation. So this here is the, okay, benzoylation of phenol. Now here is the formation of the ester. Formation of the ester. So that means we can say the esterification. This is also one of the reaction called esterification reaction. Okay. Now here how the, okay, benzolation of the phenols takes place. Simple, that Schotten-Bowman reaction, okay, is the reaction between here phenol plus, right? So benzolation, that's come from the benzoyl chloride like that. Okay, benzoyl chloride. So this is the benzyl ring. So here the, okay, I can start to write here. This is the C double bond oxygen. Now here is the Cl. See, this is the benzoyl. Okay, so I just, okay, this is the benzoyl, right, part. Okay, as we, okay, write in the previous example, this was the pyrite. This is the acetyl group. So this is the benzoyl group. Now here this benzoyl group is replace this hydrogen. Now this hydrogen is removed, okay, as the high shell. Then in presence of this our, okay, so alkaline, slightly alkaline solution. In this slightly alkaline solution. So that means in the alkaline solution, that means, okay, aqueous sodium hydroxide, you can write aqueous sodium hydroxide. So we can write aqueous sodium hydroxide. So this, okay, benzoyl, that means benzolation of the phenols. We just remove this essential and it's formed our product like this. So now here, okay, let me write like this. Let me start to write here oxygen, then here C double bond oxygen, then again the another ring is formed here. So here 2, that means, okay, here the, okay, one of the, okay, functioning group is written here, that is the our ester group. Okay, now this is the esterification of the our, okay, reaction, that is what is Schotten-Bowman reaction. This is the reaction between the phenol and benzoyl chloride. This is the phenol and this is the what, benzoyl chloride. Now this benzolation, okay, takes place in the our phenol and it's from the ester. So what is the name of this compound? That is the, we write phenyl. This is the phenyl group. Okay, so the name of the compound is phenyl benzoate. So this reaction is what we call a Schotten-Bowman reaction. Okay, so especially in this Schotten-Bowman reaction, that is the benzolation of the phenol. So in this reaction, phenol reacts with the benzoyl chloride in presence of the aqueous sodium hydroxide. It forms the ester. What's the name of the compound? Phenyl benzoate. This is the ester. Okay, this reaction what we call a Schotten-Bowman reaction. Don't forget, understand. Okay. Next reaction, that is the last one. Okay, I just want to share. That is the coupling reaction number 4. coupling reaction. Okay, coupling means okay, two substance it's form the one substance. That is what we call coupling here. So in our phenol, what is the coupling reaction in our phenol? That is the reaction between the phenol. I write a phenol, just write like this. This is the ring. Okay, now I write a phenol here. This is the phenol. Okay, OH group is present here, but one of the hydrogen I just write here in the para position, 1,4 position, one of the hydrogen I am using here. In the coupling reaction, this is the reaction between the phenol. This is the reaction between the phenol and okay. So I write the one of the substance, one of the reaction. Okay. So that is I write a triple bond and then Cl. This should be the minus. This should be the plus. So now it reacts with the phenol, right? So now this is a Cl. What is the name of this compound? Normally we used to draw like this. Okay. Normally we used to draw like this. This is the minus charge, this is the plus charge. So this compound I write in the form of this. So what is the name of this compound? This is the benzene diazonium chloride. This is the benzene diazonium chloride, right? So when the phenol is treated with the benzene diazonium chloride, so okay, slightly alkaline solution. Slightly alkaline solution. Okay, what is the pH of this solution maintained? That is the pH 9. Okay, under this solution medium, so the benzene diazonium chloride coupling with the phenol. So how the coupling products form here? The products formed here. See, this hydrogen we remove, this Cl we remove here, and the remaining part it's joined together. And how to product? Let me write here. This is our phenol, right? So this is the phenol part. This hydrogen we remove, right? So this remaining part is joined with the nitrogen, and this triple bonds now it's become the double bonds remain here, and then single bond, and it forms the benzene ring now here. So this is the one of the this. If this nitrogen change between the two substances, that is what we call the azo. This is the azo product. So the compounds containing the azo group. So always the we have the color, that is the dye. What is the color of this? That is the orange dye. That's the color, right? So what is the name of this product is okay? So here this is the para position. Now we can say that what is the, we start counting 1 2 3 4 4 hydroxy, we can see 4 hydroxy, right? So the ring between the benzene is from the azo, so we write azobenzene. So what is the color of the azobenzene? That is the orange dye, right? So here the important is the coupling reaction is the between the phenol and the benzene diazonium chloride. It forms the orange dye, right? What the orange dye is containing this bond, K double bond N, that is the azo dye. That is what is called azo group. Okay, so the compound is what we call 4-hydroxy azobenzene. In this compound, this group is present. So that is the compound 4. What is the name of the reaction? That is the coupling reaction. These are the important reaction of the phenols, and these are the name reaction. Okay, so in your organic chemistry, name reactions are very important. Okay, sometimes they are asking the name reaction, sometimes they are asking the giving the chemical reaction and asking the name of the reaction. By giving the name of the reaction, they asking the how the reactions takes place. So they asking, and here some case specific questions they may be put up in the multiple choice in your complete examination. What the thing is that as I mentioned here, coupling reaction between the phenol and benzene diazonium chloride, the azo compound is formed or orange dye is formed. What is the group present in the products form? That is, they mentioned this one or they mentioned something else. So if it's not the correct one, so please remember here this group is important to our dye, that is the azo dye, right? So similarly other compound, other reaction, Reimer reaction, Kolbe reaction and Scotton-Bowman reaction. So how is the reactions written and how the reaction takes place? You just go through it and you try to remember it. These are the very important. Okay, so it's mainly focused in your our theoretical exam as well as the competitive examination. Okay, so when you have if you found any doubt, okay, from my lecture which I given to you, okay, just you can contact, you can send a comment, okay, to the my WhatsApp group which I given to the my YouTube channel, right? Okay, please, okay, enjoy my lecture. Okay, see you then on other next classes, right?